What's up everybody, Chris here with another Chris Course, finally back after a long hiatus. Had a few things going on that threw me off a bit, but nevertheless I'm back and I'm ready to provide you guys with some killer dev tutorials. So, this is what we're going to create in this episode. We're going to cover how to use HTML, Canvas, and JavaScript to first create the effect of circular motion. And then once we're done with that, we're going to add interactivity to this so the spinning portal thing actually follows your mouse wherever you move it, creating for a really cool visual effect. This is a great way to understand how to integrate both math and physics into code, and is useful for things such as game development and creating wow-worthy interactions for your website. So without further ado, let's go ahead and get started by digging into some of the core concepts. When it comes to creating circular motion using HTML Canvas, we need to own in on a few particular math skills. Specifically, we need to understand what radians are and how sine and cosine functions work. If you're new to radians, radians are essentially another way to measure the openness of an angle. You're probably used to measuring angles with degrees, but when it comes to using math functions built into JavaScript, knowing a bit of radian knowledge will go a long way towards improving your aptitude as a developer. So how do we measure angles using radians? Well, 1 radian represents the openness of an angle in which a circle's radius, this line right here, is equal to the angle's outer arc. If this outer arc was stretched out straight, it would be exactly equal to the length of the circle's radius. If we start to open our angle more, eventually we'll get to the halfway mark, which is equal to 3.14 radians, otherwise known as pi radians, and if we go full circle, we say that the angle created is equal to 2 pi radians. Now the reason we're learning about radians is due to the fact that the two functions we need to create circular motion, sine and cosine, only take angles and radians as their argument. Sine and cosine are trigonometric functions. This is just a fancy way of saying that these two functions take an argument and spit out a result. The result, a number from -1 to 1, represents a ratio produced when two sides of a triangle are compared against each other. Sine is a function that takes the openness of an angle and radians as an argument and returns to us the ratio produced if we were to draw out a triangle and divide the triangle's opposite side by the triangle's hypotenuse, which is the longest line on a right triangle. So if we were to pass an angle of 1 radian into our sine function, we'd be returned with a ratio of 0.84, meaning that the opposite side of this right triangle is 84% of the size of our circle's radius. If we were to keep increasing the size of our angle, eventually our opposite side would be exactly the length of our radius, giving us a ratio of 1. And if we were to keep on going, eventually we'll get into the lower half of the circle, which will return to us a ratio of a negative value. Cosine will do the same thing, but instead of returning the ratio of the triangle's opposite side to its hypotenuse, cosine will return to us the ratio produced from the triangle's adjacent side, divided by its hypotenuse. So using cosine here, we'll get a ratio of 1, while if we were to use sine here, we get a ratio of 0. Now, since these functions return to us numbers ranging from -1 to 1, based on the angle we pass through, if we start to increase our angle size over time, we start to retrieve all the values ranging from -1 to 1, and if we start to add these values to, let's say, a circle's x and y coordinates, we'll effectively be producing an oscillating movement, which when done right, will create the effect of circular motion. So with the concepts out of the way, let's go head on over to our text editors and let's get coding. Alright, what's up everyone? So we are going to learn how to code circular motion. So to get started, the first thing I'm going to do is I'm going to create a new Canvas project. I'm going to use an alfred command that I created to do this. Essentially, all I have to do is type in mkcanv, which stands for make canvas, and then the name of my project, like so. I think this is 5 because I've done this about 5 times already. And then I hit enter, and it's going to bootstrap everything I need to get this project opened up in the browser. It's essentially making project setup really quickly because setting this up on your own can be very tedious, and really I just got sick of it, so I automated the task altogether. You'll see over here in terminal, it's currently installing all of our dependencies, and then once it's done with that, it opens up our project in the browser. And if you'd like to learn how to do this, I recently created a blog which details this whole thing out step by step in regards to getting it set up on your computer. The blog post shows you how to do it with Three.js, but you can really change out the code for your commands so that it also works with the HTML Canvas boilerplate that I have on GitHub. But if you don't want to do any of that, go ahead and check out the Git repo that I have in the description, clone it up, download all of the dependencies within it, and then run Webpack, and you should be in the exact same location I am right now. The reason we're using Webpack is because we can do cool things, such as use ES6, which is the next generation of JavaScript, and also live reload our page so that whenever we make a change over here, we have our browser reloaded. And you can see I just made a bug, so now nothing is working. So you'll see that we have all this boilerplate code over here, and this is just code that I typically use within every Canvas project that I do. So really, to get started with creating circular motion, we don't really need this HTML Canvas boilerplate thing right here at all. So we can head down to our animate loop and get rid of c.filled text. And if we save that, you'll see our browser updates and it is now gone. But to create circular motion, the first thing we need is some sort of particle on our screen. So we are going to be creating a particle object. And let's go ahead and get this actually on our screen. To get this particle on our screen, well, we need to create a particle. So we have our outline, we have our blueprint for a particle right here. But now we need to actually create one and animate it. We need to call this update function to draw it on the screen. So we know we're going to have multiple particles because if we look at our example over here, you'll see that we have multiple particles running instead of just one. It'd be kind of boring if we only had one here. So we want to make sure that we have the ability to create and animate multiple particles at a time. So since we know we need to be creating multiple particles, we are going to be storing these particles within an array. So you'll see right here, particles. That is not what I want, particles. We are storing all of our particles within an array, but the second thing we need to do is we need to now create particles and push them into an array. So to push them into this array, we're going to say particles.push, and I'm going to add a semicolon right here real quick. We're going to say particles.push a new particle. And our particle object takes a few arguments. It takes an x value, a y value, a radius, and a color. So since we want this to be spawned in the middle of our screen, we're going to say canvas.width divided by 2, canvas.height divided by 2 for our y coordinate, and then our radius. Let's go ahead and set it something simple for now, 5, and let's go ahead and give this a color of blue. So if we save that, and let's go ahead and console log things out to make sure that we're actually pushing a particle into our particles array. We'll console log out particles. And you'll see if we refresh the page, we now have an array of 400 particles. Really, we only want to focus on one right now, and eventually, once we understand how to move that one particle, we'll get on to adding more. So instead of creating 400 particles, we're just going to say create one particle instead. You'll see we have one particle. But now we need to actually draw this on the screen. So to draw this on the screen, we need to call the particles update function right here, which in return calls this draw function. And to do this, we're going to head on over to our animate loop. We can uncomment this right here, because this is how you animate multiple objects at once. We're going to say for each of our particles, we want to select a particle. And with that particle object, we are going to call its update method. So as soon as we save this, you'll see we now have one particle on the screen, which is perfect. But now we need to actually get this thing moving. And to get this thing moving in a circular motion, well, this is where we need to use radians and our sine and cosine functions that we learned about. So the first thing we're going to do is we're going to add a new property called this.radians. So the first thing we're going to do is we're just going to get this circle moving in one direction. And to do that, we're going to be altering the particle's x coordinate. And we can say this x is equal to this x plus 1. And you'll see now it is moving to the right. But we don't want it to just move to the right. We want it to be moving in an oscillating motion. So back and forth, back and forth. And to do so, we need to use a sine or a cosine function. So we're going to say, instead of adding 1 to this.x, we're going to say math.cosine. And then our cosine function takes radians for its argument. So since it takes radians for its argument, we want to create a new property up here called radians. And this is going to be equal to, let's just say 0 for the time being. And we're going to pass this through our math.cosine function. So this.radians. We want to set this.x equal to math.cosine with our radians inside of it, which will give us a value anywhere from -1 to 1. So if we save this right now, you're going to see that our y value is still equal to our inner height divided by 2, but our x value is equal to either -1 or 1, any value between that right now. That's not really what we want. We want to make sure that our x value is still in the middle of the screen, But we want to make sure we're not adding x to itself, otherwise it's going to throw the motion off a bit. So instead of adding this.x to itself, we're going to reference the particle's original positioning. And this is going to make sure that we're adding a value of -1 to 1 onto the original location of the particle without throwing things out of whack. So if we do that, you'll now see that we have our particle back in the middle, but it's currently not moving or doing anything. And that is because we need to increase our radians over time. And as we do that, we're going to start getting values from -1 to 1. So let's go ahead and do that now. We're going to say, let's go ahead and do this before that. We're going to move these points over time by saying this dot radians is equal to this dot velocity. So since we're adding velocity onto this, we need to create a new property right here. And this is going to determine the speed in which the particle actually moves. So we can say this dot velocity is equal to let's start off with 0.05. All right, so, oops, excuse me, sorry about that. So as soon as we go ahead and add this line of code, if we look very closely, you'll see that the circle is moving ever so slightly. But it's so slight, it's not even really noticeable. We want to make sure that we see obvious motion from the circle. So it's moving from a value of -1 to 1. And we can check this by console logging out our math.cosine function over time. And you'll see it's going from -1 to 1, back and forth, back and forth. But like I said, we want to make sure that this is visible. And in order to do this, we want to go ahead and multiply this by a larger value. So we're going to say that this is equal to 100. And actually, let's go ahead and console log this out again so you can get a better idea of what happens once we add this 100 here. We'll go ahead and say console log math cosine again, save this. And the first thing you notice is that our circle is moving left and right in a much larger motion. It's moving between values of 100 and -100. And we're still seeing the same thing right here because we're not actually multiplying this function by 100 right now. But as soon as we add it, you'll see now we're sifting between values of 100 to a -100. And whenever we add this onto the x's, our particle's original x coordinate, and set the particle's new x coordinate, well, it's creating this oscillation effect as a result. And this is the first step to creating circular motion. But the second step is we want to alter not only our x coordinate, we want to alter our y coordinate as well. So we're going to say this dot y is equal to y. And you may think as soon as we add this and save things that it would work, but once we save it, you'll see that the circle is actually moving in a diagonal direction. That's not what we want. The reason for this is because we're using cosine in two spots. In order to get that circular effect, we need to use sine instead. And as soon as we add sine there, you'll see we just created the effect of circular motion. So really, this is all there is to it. The most important thing I want you to remember is creating circular motion all comes down to these two functions right here and incrementing the radians that you pass through it. And once you add that and add it to an x and y coordinate, well, you then get the effect of circular motion. But we're not done just yet. We want to create exactly what we saw with an example over here. We want to create something that actually has multiple particles, particles that follow the mouse on movement, kind of with a drag effect. We also want multiple colors on these. So let's go ahead and do that now. First thing we're going to do is create multiple particles instead of just one. Let's go ahead and delete this console log statement. And let's go ahead and add multiple particles. To add multiple particles, we'll go down to init and say we want to create 50 particles instead of just one. So we created 50, but you'll see that the issue is all 50 particles are being drawn on top of each other instead of different locations around here. So the reasoning for this is we are currently spawning all of our particles on one path within the circle. If we're going to refresh the page, you'll see that all of our particles are being spawned right here at 0, because that is when a circle's angle is equal to 0 radians. So instead of spawning our particles in one point where radians are equal to 0, we want to make sure that we're spawning our particles anywhere along this circle's path. And to do so, we want to add a math.random value here instead of a hard-coded value of 0. And we want to say get a random value anywhere from 0 to math pi times 2. Because math pi times 2 is when an angle travels all the way from one side of the circle back around, doing a full 360 loop. So we are going to say math random times math pi times 2. And as soon as we do that, you'll now see that we have circles being spawned in different locations on the screen. Now this is the first step to creating that cool little effect that we had in the example. But really, the issue here is that all of these circles are being spawned within the same distance from the center. We want to make sure that they're being spawned in random distances rather than the same one. So to spawn these circles with random distances from the center, we don't want to spawn them with a hard-coded value of 100. We want to spawn them with a random value instead. Let's just say anywhere from 50 to 120. So to get a random value, we're going to use this utility function right here, random int from range. We're going to say get a random integer from 50 to 120 for our x coordinate. We go ahead and save that. You see that we get this really wild result going on right here. And the reasoning for this is because each time we run this update function, we're essentially getting another integer. We're generating a new random value, which goes ahead and throws everything off. It doesn't really give us a smooth motion like we want. We want to make sure that we're generating a random value, but we're only generating it once rather than each time this update function is ran. So instead of using this function within update, we are going to set this dot distance from center. And this is going to have both an x and a y property within it. So we're going to set both x and y equal to a random integer from a range of 50 to 120. And now we need to reference this within our circular motion path. And let's go ahead and comment this out real quick. Say that this is circular motion right here. So we want to go ahead and multiply our circular motion by distance from center, this dot distance from center dot x. And this is going to go ahead and randomize our circle's distance from the center of its spawn location. So if we save this, you'll see that we have an error somewhere. Let's see, unexpected token. Okay, so let's see, where is this? All right, so the error is I never set an equal sign right here. And once we save that, you now see we get a really wild looking effect here. And this is actually pretty cool. I would probably pursue this myself. If this might end up being cooler than the effect we're actually going for. But if we're to go off the example, this isn't really what we want. We want something that has the circles moving in a smooth path. But right now they're kind of going in a 3D looking path. And the reasoning for this is due to the fact that we're currently only referencing our x coordinate. But even if we start referencing our y coordinate over here within our y circular motion function, you're going to see we just kind of further 3Dize our canvas piece right now. So really, the issue here is that we're generating a random value, a random distance from the center for each of our circles for both x and y, when we really want to make sure that both x and y have the same random value rather than the different ones. So to fix this, we're just going to go ahead and delete this object altogether. We're going to say random int from range 50 to 120, so we only have one that's being generated. Then we can get rid of the x, get rid of the y. And as soon as we do that, this is the motion we're going for. This is the distances from the center that we want in order to create that example effect. So next thing is going to be actually creating the trails that we saw as well. So to create a trail effect is actually pretty easy. We're going to go ahead on down to animate. Instead of using clearRect, this is the function that refreshes the screen, gives us a new slate to draw on each time we call particle.update. You'll see if I comment this out right now and save it, our circles are just drawn on top of each other, and we don't actually get that. We don't actually get the screen cleared each time this animate loop is ran. Instead of using clearRect, we are going to use fillRect, and we're going to set our fill style equal to a value of RGBA 255, 255, 255, which is going to be white. We're going to give it an opacity of 0.05. And as soon as we save that, you'll see we now have a trail effect. So how this works is we're essentially creating a rectangle to be drawn on top of our circles each time we run this animate loop. So for each frame, we're drawing a new white rectangle on top of it, and that rectangle has a very slight transparency, which once we start layering each of these transparencies on top of each other, we start to get this trail effect as a result. But this isn't really the trails I would say we're looking for. If you look closely, you'll see that these trails have ridges on them, and that's due to the shape that we're drawing within our draw function. Since we're using an arc to draw this, it creates not so smooth effect, not the smooth effect that we want. So instead of using an arc, we're actually going to be using a line instead. So let's go ahead and delete our arc, our fill style, and our fill. And we're going to say c.move2. Beneath that, we're going to say c.line2. And then finally, we're going to say c.stroke. And I should actually specify, we need to set our stroke style equal to the color of whatever we set our particle to. So this is going to be equal to this dot color. And then we need to set our line width equal to our radius. Okay, cool. So c.move2, the whole idea behind creating a smooth looking trail is we're going to be taking our particle's previous location within the previous frame and then drawing a line to the particle's new location in the new frame. So you can see right here, c.move2, this is going to take the coordinates for the particle's previous frame, and this is going to take the coordinates for the particle's new frame. So since we know that this is going to be the particle's new location, we're going to say this.x, this.y, but we need the old particle's location. So in order to do that, we need to grab it from this.update, and we're going to create a new variable called last point. This is going to be equal to x, this.x, and then y is going to be equal to this.y. And this is going to give us the particle's last point before we actually edit anything. Because you'll see right here, this is where we edit our x and our y value. But since we're storing this within a last point variable right here before we edit anything, well, we're essentially getting the last point of where our particle was. So if we go ahead and pass this into our draw function, and since we're passing it in, we need to make sure that we're adding it as an argument right here, we can go ahead and access the last point's x value and the last point's y value. And as soon as we do that, you'll now see that we have a smooth looking animation here. Much more smoother than if we were to use that circular effect. But it's still not looking exactly like we want at the moment. And one of the reasonings behind this is because we want to make sure that these are being spawned with different radii sizes. So to do so, we currently have a hard-coded radii of 5 for all of our particles. We want to make sure that this is randomized, so we're going to say, for each time this for loop is ran, for each individual particle, give us a new radius that is randomly generated between, let's just say, the size of 1 to 2. So to get a size of 1 to 2, we want to say math.random, which will go ahead and give us any value from 0 to 1. Multiply it by 2, which will give us any value from 0 to 2. But we want to make sure that this is only from 1 to 2. We're going to wrap these in parentheses, add 1 onto the end, and this will go ahead and give us a value anywhere from 1 to 2 rather than 0 to 2. So we take the radius, replace 5 with the randomly generated radius. You'll see now our particles are actually being spawned at slightly different sizes, and this creates a much smoother looking particle trail as a result. All right, cool. So we have this going on. Let's go ahead and colorize this because our blue color really isn't cutting it out. We want something, a color scheme or something that makes things look a lot better. So I'm going to go ahead and copy over the color scheme I have over here. You can go ahead and copy and paste these colors as well if you'd like to use them, or you can use your own color palette, replacing these hexadecimal values with whatever you'd like. So I'm going to go ahead and take these colors, this color array, and I'm going to use it within this random color function, this utility function right here. This is going to return a random color from an array of colors, which we already created. And we're going to say, instead of using blue, get a random color from our random color array. And if we save that, now we have our colors being outputted over here in the browser. And we are really close to creating what we have over here. And this is looking pretty darn cool, I would say. But the next thing is we need to create this mouse movement effect. We know how to create circular motion. We know how to make things look Pretty cool, but we don't have any interactivity at the moment. So to add the interactivity, we need to make use of our mouse. Our mouse's X and Y coordinate, which we're already setting within this event listener right here. But now we need to actually make use of this X and Y coordinate. So to make use of this, we need to make sure that whenever we move our mouse, that the X and Y positioning of our circle, or the center of our particles, is moving along with the mouse. So instead of referencing X as our initial coordinate, we're going to reference mouse.x instead. And instead of referencing the initial Y location, we're going to reference our mouse's Y location instead as well. So once we do that, we can start moving things around, and you'll see that it's now following our mouse wherever it goes. Super simple. But as we move it, you'll see that we're getting a really jaggedy effect, and it's not really anywhere near as smooth as we saw with an example. This is because the center of the particles are moving along with the mouse real time rather than creating a drag effect, which we need to add a little bit more extra code to achieve. So to create the drag effect, we need to do something similar to what we're doing right here to create the particle trail. To create the particle trail, we're connecting the particle's last location with the new location. To create the drag between the mouse and the center of our particles, we need references our mouse's previous location and our mouse's new location. So in order to do that, we are going to be creating a new property to reference our mouse's last position. We'll say this.lastMouse is equal to X, where we initially spawn the center of our particles, and Y. So this is where our last mouse is going to start. But now we need to actually create the drag effect. So this is where we're going to create the drag effect, right above where we're actually setting our X and Y coordinate. So we want to say this.lastMouse is going to be equal to mouse.x minus this.lastMouse.x times a percentage. So we want to say times 0.05. All right, so how this works is we are getting the difference between our mouse's current X coordinate and our mouse's previous X coordinate. So let's say we have our mouse up here in the top left-hand corner. Excuse me, let's go ahead and scroll back down real quick. Let's say we have our mouse in the position of top left-hand corner over here, an X position of 0. If we were to move our mouse over here to a position of 100, well, that'll go ahead and equate this right here to a value of 100. The distance between our mouse's previous and new location is 100 pixels. If we were to multiply that by 0.05, that means the center of our circle isn't going to move by a distance of 100 right off the bat. It's only going to move by a distance of 5 pixels instead. So instead of moving by 100 pixels, we're moving by 5. And as a result, since we're only moving by 5, we're going to get a nice trail effect where this is dragging instead of following our mouse exactly. So instead of referencing our mouse.x, we want to reference our mouse's last X coordinate instead. So if we paste that in there, now you'll see whenever we move our mouse along the X axis that we have a nice trail effect as a result. But it doesn't really work for our Y at the moment. That's because we need to do the same thing for our Y coordinate as well. So we're going to say last mouse Y, mouse Y, and last mouse Y. And then we're going to replace our current mouse coordinate with this last mouse Y, save things, and now we have that super nice smooth trail effect that we were going for. And I think we just completed the tutorial. This looks really cool. It's a really nice effect to create a circular motion, a drag effect. Really play around with the colors of this and even the coordinates and randomization stuff. You can come up with really, really cool things just by randomizing different values within here. I really recommend it. But this is how you create circular motion. This is how you get things moving with drag. And this is how you create trail effects to create something that you can be proud of, something that you can show off to your friends or put on your website. So I hope you guys enjoyed. It's been quite the lesson. We covered radians, we covered sine, we covered cosine, a little bit of trigonometry. If you enjoyed this video, go ahead and leave a like, subscribe. Feel free to donate to me on Patreon. I currently do not make anywhere near enough money to support myself on doing this full time. So every Patreon donation I get does help a lot because I can put more time into creating these videos for you guys. If you guys have any questions at all about the video, the code that we went over, the math behind it, feel free to leave a comment or go ahead and reach out to me on Facebook, Twitter, any method to reach out to me, and I'll be sure to answer. Otherwise, I hope you guys enjoyed, and I look forward to seeing you in the next video. Peace!